Hello, welcome to this tutorial on the video about NX CAM turning and milling. This is the part on the screen. It's a perfect classic example of how to do a mill turning on a Siemens NX. We'll apply the toolpath and how to simulate it. Simulate the toolpath that we're gonna apply to this model. Let's start. Let's go back and look at the properties of this model. Windows, get out the stuff. So we got the millimeters metric unit, this part, okay. So let's go back and create a solid start for this model. Go back and extract a code. Let's go, okay. Let's go back and extrude this. Since it's a matrix model, probably will give about 2 millimeters of stock in the front end. So we need to give and go and cut a clean face. So we'll do the second side on the sub spindle after the part transfer. It's good enough. Keep it none. Offset. Fine. Okay. Settings type. Now go back, select this one. Make it transparent. Go to menu, insert synchronous modeling. Let's give it a distance of 1 millimeter. So it's about 1. Good enough for a 1 finished path on the outer diameter. So have a nice cleanup of the stock. So if you think there'll be a run out during the cut because of the tool pressure, the vibration and different dynamics. If you need more stock for have nice clean out, you want to keep the total indicator run out to be as close as possible. So to get a perfect cylindricity, so we may need some more stock. Let's go back and edit parameters and give it 1 maybe 2 millimeter. So this is going to be a stock. Okay, let's go back and go to file, manufacturing. You have to select so create a geometry. You need to create an MCS. So we need to, in a mill turn machine or in a turning spindle, the Z-axis will be facing. This is a spindle. If it's held in the chuck, will be facing this direction. Go back and change that. Okay, X will be X, Z, and Y. If you want to put the MCS, the data MCC side of the face of the part, you can go back and move it. So right here I say MCS. Go back and create an operation. tool. Let's talk about the tool geometry for turning. For if you have a for roughing, you need to remove a lot of stock. Let's select a CNMG or a CCMT if you want a positive rake. I will go with the negative rake. It's being we need to remove a lot of stock fast. So let's go with the CAM cycle for roughing. It's better to select a 80-degree diamond insert. That's going to be a CNMG. I will cover all that alphabets, what it means for each alphabet, what it means for the tool, how to select the shank size. So right now we'll go back and select the CNMG insert. Okay, it's 80-degree OD cutting, left hand insert. Select OK. Take from the library. Select the folder, use 10 folder. Looks a bit good. You can look at the details here. Shank width, the length of the stock. So length of the stick tool is going to be 150 millimeter. That's about 6 inches roughly. So that sounds about right. If you need to cut it off, you can cut the shank so it will fit in the turret right. Let's give it OK. So we get go back and look at the tools. We get one tool. Let's go back and select 55-degree diamond for finishing, or a 35 diamond. So create a tool, either VCMT or DCGT. Go back and select this 55 degree, or okay, let's go this one again. OD cutting 55 length level for left hand cutting. To determine the hand of the tool, you need to determine so select the spindle rotation. The spindle need to go into the top of the insert. So when you look at the way when the lathe is spinning, so the spindle is going to turn this direction. The top of the holder needs to face the spindle, go into the spindle. I will cover it in all the steps in the simulation. We'll do a very good simulation as a follow-up on this video. 55, looking good, cutting edge length, nose radius, orient angle, holder, turn holder. Okay, presence of the right. So we set the MCS, we set up the tooling. Now we need to go and apply the toolpath for the OD. We will come back and create the toolpath tool holder for the grooving, face groove. These are all the flats are all done in the milling, and we have the drill and tapping for the screw holes. Let's talk about a type of stock we can use to make this part. Now on the screen you are seeing a solid stock. Since it's we have a through hole in the part model, there's a possibility that we can use a cannulated stock. If you think that we need to save the material cost, if it's going to be expensive material, like either we have to use a titanium or stainless steel, or even Inconel or some high strength alloys, we may need to think about using cannulated stock. But if you're going to use like a low carbon or medium carbon steel or something aluminum, the solid stock may be fine as it is. So now let's create a stock to do the turning operations, and then we do the milling. We can go back and hide the solid stock we created. Just go hide it. So now we got a part model right here. On the MCS we just created, we have an MCS made for milling operations. The milling op, as you can see, we had to make the flats using the milling op. We had to use an animal to go and mill the flats. We had to drill it and we had to tap it on the 4 holes on the periphery. So come back here, you're seeing all turning up, and then you have a face groove. So on the back side, we will be doing the sub-spindle after the part transfer. We'll do all the front end work will be done on the main spindle, all the turning. We use the CNMG for roughing, we use the DNMG or VNMG for doing all the finish work. On the boarding bar, since we need to keep a positive rake, on the ID boarding bar, let's use a positive rake angle. So that means instead of CNMG, we have to use a CCMT. We have to use for a finished ID boarding, we'll use VCGT inserts. So we have to use the tip of the insert, the coating, the chip for the chip control, depending on the type of the material you're cutting. The chip control, the coating on the insert will tell you how to get the best optimum process. Now on the screen you're seeing on the left hand side, you're seeing an MCS mill created for do all the milling work. Now let's go back and create a MCS for the turning. Let's go back here, create geometry. Here are different options. Here let's go back and pick the turning. Then MCS spindle workpiece, then turn workpiece, right turning part. It's a containment boundary to create a zones where you want the tool to stay, start and go back points. Now we have an MCS spindle. Geometry needs to go underneath the geometry. That's fine. So for let's pick up the where we want our need to be on the front end. Okay, so now our z-axis to be right here. Do 90. Make it perpendicular. Select this face. Okay, z-axis, x is on the diameter, z is on the spindle linear axis. Now it's y. Looks good. It's okay. Now for the workpiece, specify part, pick the part model. For the blank, here we get pick up from the geometry, offset from part, bounding block, bounding cylinder. You can select the stock where you want on the Z, the front end of the part model. They'll be using, you need to use a facing tool to do a clean cut, and a backside stock will be, you need to give again at 1 millimeter for once do all the front op, part transfer, cut off, part transfer, and doing the operations on the second spindle. We need some face for second side cleanup. Or if you have to go back and select part outline. I'm going to show you different options of how you can define the stock for turning. One method is either you can create the part geometry ourselves like we did, or you select go back and select a part cylinder, bounding cylinder. The third option is part outline. This we will see. Let's go 1 millimeter, 1 millimeter. So if you want to use a cannulated stock, we can go offset from part. Let's go back and get it. So now we can have different options, specify part boundaries. Either we can have different options how we want to select. Either we can select a face or we can select the curve. We can if you select a curve, Set it automatic. Blank boundaries. Need to select a length, however you want it. So if you have 200 millimeter, we need to find out what's so about 142.87. So let's call it 143 on the radius. So it's going to be 286 on the diameter. Since for a cleaning start, let's get 288. Now for the distance, from this face to back face, about 360 millimeter. So give it a 360 plus 1 millimeter on the front end, on the back end, so 362. Mounting position, let's say at headstock. So 362. Say one more time. We could select a projected distance. Okay, let's say about it right. Arc center 360. So 360. Okay, 362. Okay. So now you can see the stock boundary created by the NX automatically for you. Instead of you have to define the model, it's created for you. Now if we have to select I will go back and select each of the geometry to double check we selected the right things. So MCS spindle, that's a datum species for the turning operations. Go back and select the workpiece. Now we do have specified the part, there's a part model that we selected, which is the finished model, which you can see the highlighted on the screen. That's right. We don't have to specify the blank on the workpiece geometry. Reason being is, as I told you, there's a different options of selecting the blank, which you did in the training workpiece. Now we did specify the part boundary. We specify the blank boundary. We have different options to specifying the blank boundary. We said that we're going to go 364 for the length, for the diameter 288. The mounting point, we can select a different place where you want to mount. Let's go at headstock and pick up the center point of this one. So now we have the stock defined. Since the nice point in the NX turning is the NX will create a part boundary for you when you are going and selecting the NX turning. The NX turning will create a 2D geometry that will make it make your life a lot easier in selecting the profiles curves. If you want to offset the curves, for different operations, for containment, for creating a calculated stock. It will be of immense help. If you want to see the 2D geometry created by NX, hit Ctrl W, or you can go back and select in menu, show and hide options. I'm going to do Ctrl W. Now let's hide the solid body. You can see that NX created this profile for you. Now you can see that this is a 2D profile created by NX. So if you want to go back and look at the blank geometry, the stock that we defined, right there is the stock that we defined. So there's a different option of selecting the stock. Right now it's a bar stock, it's a solid stock. Since there's an option that we can use a calculated stock to save on the material cost, we'll go back and select the curve. As I told you, this is one good thing about NX. Since the 2D geometry is created for you, all you need to do is select the same curve and give it a distance. Curves. Now look for options of what's since it's a millimetric part, we may have to give it a distance of 1 millimeter. Now this will be a calculated stock. This stock is not enough for cleanup. You may have to offset it by the distance of 2 millimeter. So now you see there is the calculated stock boundary. So it's not a calculator, I'm sorry. It's going to be, we're going to use a casting or a forging. It's going to be either a gross shape forging. Net shape forgings are really close to the size of the part model. It's best to, if you think it's going to be more of a run out and one you need to be clean up, or there's a porosity, depends on what type of forging. If it's a cold forge, you don't have that kind of problem with the porosity. If it's a hot forge, yeah, you may have to give it more stock. Select the gross forging. That's a forged component where you have to go and do only the medium finish and then a finish path for the OD, and same thing with the ID. Now since we are going to use solid stock, you may have to go back and define the stock as from bar stock, and length to be scale 392, diameter to be 292. Now that we selected the part model and the stock, now a couple of things we need to do before starting the toolpath. One is selecting the avoidance geometry and the containment geometry. If you look at the left hand screen here, the MCS spindle is the parent of the workpiece, and workpiece is the children of the MCS spindle. Training workpiece is the children of a workpiece, the main workpiece. Either you can select the part model on the blank model in the workpiece, or like we did, we can select in the turning workpiece. Now we need to create a geometry view, create geometry, containment and avoidance. We will select the avoidance as the parent of containment. So avoidance will be the children of turning workpiece, and containment will be a children of the avoidance. Avoidance and turning workpiece. As you can see on the legend on the label right here, as there's a from point, start point, approach point. If you have one more, as you can give it a different more number of approach points to more and refine the toolpath. So the departure point. So it's a go home point. Now if you want to, we got a motion to start from point, specify. Let's put it right here. So, you know, it's most of the OD turning will be done in the sub spindle. I mean the main spindle right here up to this point will be all done in the main spindle OD turning. The ID turning will be done up to here. the backboring will be done on the sub-spindle. So we need to be careful on how we approach the toolpath. We may have to select the two different avoidance geometry for the OD tuning tools and a different avoidance for the ID tuning tools. This avoidance we probably will name it as a OD avoidance. Motion to start point, keep it direct. Since we're going to use there are two options like we thought about using it. One, either use forging or casting that simulates the mimics the profile of the part model, or we can use a bar stock. Since the bar stock is going to be about 2 millimeter bigger on the size than the part model, we need to give it a motion to start point as right here. We need there to pick the coordinates. Yeah, that sounds about right. Maybe y, so the center line, that's fine. X, the okay, approach point. Containment restaurant, OD avoidance. Copy it and paste it. Rename it as a we need to open the window and edit it as we see fit. For ID tools, we need to select the boarding bar will start from here. That's going to be a okay from point. Maybe yeah, we can from here, motion to start point, direct. So this one is going to be right here, approach point. Now that we have avoidance for both the OD tuning and the ID tuning, the next thing we need to do is set up the containment. Containment is going to be children of both avoidance geometry. So basically right here we can select either the radial trimming or axial trimming. Radial trimming means what it means. It's on the OD. If you want to keep the OD tuning tool to not go beyond this point, we can go and select this one, this line. There's going to be a point for radial trim plane. This for the axial trim plane, we know that the stock is going to be held in a chuck. The main spindle chuck will be extending up to this point, where we will be doing OD tuning up to here. Maybe for an axial trim plane, we go back and because we don't want to take the turning tool and run into the chuck that's used to hold the stock. So it's a safety thing to keep it a avoidance zone for any collision. It's a good way to be stop the toolpath from going into the unsafe zones. Pick a point here. Move it a little bit of 144, 137. Maybe we can give it a little bit down. Oops, sorry, wrong guys. give it as a rounding number. That's my axial trim plane 1, axial trim plane 2, put it over here. So all the tool path will be contained within these two axial planes, and the radial, all the OD turning tools will be contained within the radial plane of this distance. So all the cutting will be taking place right here for the OD turning tool paths. For the boring bar, for the ID boring bar, we will do the same thing. We will select the axial trim plane up to this point, little beyond 2 millimeter beyond here, because we will come back. The ID boring bar will come and do all the boring and then do this chamfer and take it away. We will have a through hole with probably using a drill bit. We have selected OD turning tools. We will now create the ID turning tools. ID turning tools is better to create the positive sharper edges for the insert, so there will be a better chip clearance containing the ID. Again, for roughing, we need to select the ID 80 degree diamond left hand tool. See, diamond top side nose radius 1.2 millimeter. It's about 50 thousandths radius, nose radius. So that's good. We need a beefy, strong edge radius to remove a lot of stock to keep the cycle time effective. Orient angle 275, cutting edge length. Okay, holder, Houston holder, round bar. Since ID turning, it's going to be a round bar. Either you can use a half-inch shank, or since it's a metric part, let's for shank width use a 30 millimeter. Okay, that sounds about right. Looking good. Hit OK. Now we have a OD turning 80. We need to create an ID. Face grooving bar, ID turning tools, roughing and rough drill bit, rough ID, and finish ID. Finish ID, we will select this one, ID 55 diamond left hand turning tool. ID 55 diamond top side, left hand holder, use turn holder. Okay, since you have more clearance, we're able to go and finish give it a nice finish with without any vibration. Selecting a drill bit, spot drilling and drilling. See what type of drill size we need. We need drill diameter of about that's too much. You can either go back and do the measure analyze toolpath and find out exact size we need. It's going to be a rough boring bar. I mean, it's just a clearance for that, so that you can come back with a boring bar to make the profile. You can go back and be able to use some kind of small drill bits. Let's select 50 millimeter drill bit. It's too small. Okay. Point angle. It's going to be, we want to be self-centering, 138. 60. Yeah, that sounds about right. Okay. Holder. It's going to be a card holder. Length, let's say 300. Okay. Shank. Define shank. Shank diameter. Let's give it 70. Shank length 200. Okay. Now we're ready to start the OD cutting toolpath. Create operation. We need to come back with we need to do the roughing, finishing, do the face cut, roughing, finishing. Containment. Methods. Then OD. Linear zig. Omit beyond all the we did selected we have a little problem with the geometry. Let's go back and see what it is. Let's see why the stock did not get updated when we did our workpiece training. Looks like we got it right. We got the blank boundary defined. Why is this? Go back and select a linear zigzag. If you want to select both sides of the motion of the tool to cut, more aggressive cutting, you can go zigzag or ramping. Keep it linear zig. Have to specify lead angle, cut that 4 mm maximum. That's standard for roughing. The reversal mode, let's keep it as omit, inverse. Okay, for each one. We don't want to dig into any spots where we need a grooving tool or more refined tool with good clearance to come and clean it up. Okay. So we got the lathe spindle right about here. So the tools are stopping right here as we selected in the containment, the axial turn plane. Let's verify the toolpath. Okay, that's exact just right there. We don't want the OD tool, particularly this tool.
The IPW will always be updated on generating the toolpaths. You can even switch back and forth through drag and drop in Program Order View. As soon as you regenerate the toolpaths, the updated IPW will be considered.